we're going to take a look at something called the segment addition postulate. So the segment addition postulate states that if point B lies on a segment AC, then AB plus BC equals AC. The simple way of thinking about this is if you take a stick and you break it in two pieces, you have two smaller pieces. But if you take those two pieces and you push them back together again, you have your original stick. And that is all the segment addition postulate is saying. It's saying I had this original segment, AC, and I broke it into two pieces using a point or a line or a ray. And now I have two littler segments that if I put them back together again, I get my big segment. That's all it says, okay? So again, we really want to note when we're writing our answers for this, we want to be careful here that we're remembering that AB with the segment notation above it is referring to the physical figure AB, but AB without the segment above it is the length of the segment, so a measurement. So if we wanted to say AB equals 5, we would not put the segment indicator above it so that whoever's reading your problem can see that you're talking about a measurement. All right, so let's put this to the test. So find the length XY in the figure shown below. So we're trying to find this length right here. So first we want to apply our segment addition postulate. And this is a step that you don't have to do every time once you get used to it, but it helps getting off the ground and sort of getting these problems started. So we're always going to start the segment addition postulate by listing our two little segments. So XY, the measurement of XY, right? So I'm not putting the notation because I am talking about a measurement, plus YZ, so those are my two little plus little, equals my big one, my big segment, which is XZ. Now we can substitute in our values. We didn't have a value for XY, that's what we're trying to find, so we're going to leave that be, but we know that YZ is 11 and XZ is 17. All right, so we're just going to go ahead and solve this, subtract 11 from both sides, and we find that XZ equals 6. And we're done. So we're going to go through a few more of these examples. For these, we're going to want to make sure to draw a picture of the situation and then go ahead and solve our problem. Drawing a picture will help us to visualize where all the different pieces are. So it says C is on segment BD. So we have a segment BD, and C is a point somewhere on there, not necessarily in the middle. Then it gives us some measurements. BC is 4x minus 2, CD is 5x plus 6, and BD is 31. So that's the whole big segment. So I'm just going to go ahead and mark that. Okay, so we're going to start with that apply step. So my two little segments, BC plus CD equals my big segment, BD. And then we're going to work on substituting in the information that we know. So BC is 4x minus 2 plus CD is 5x plus 6 equals BD is 31. And we just want to go ahead and solve that real quick. So we're going to go ahead and combine like terms, and we're going to get 9x plus 4 equals 31. Subtract 4 from both sides, we get 9x equals 27, which gives us x equals 3 when we divide both sides by 9. But this has asked us to find BC, so the length of BC, which we're not done yet. We need to substitute in. So we know that BC, the length of BC, is equal to 4x minus 2. So we're going to substitute in. BC equals 4 times, we just found out x is 3, minus 2, which means BC equals 10. So we're going to do a few more examples. We're not going to do all of these. You can check your notes key if you'd like to see the other ones. So let's go ahead and take a look at number 2 here. So it says B is on AC. So first thing, we're going to draw a picture. All right, and it says AB is 3x minus 7, BC is 9, and the large segment, AC, is 2x plus 10. This is slightly different because our large segment is no longer our integer value. It's now an expression. So it's just slightly different here. Okay, so let's set this up. We know that AB plus BC equals AC, and we're going to substitute in 3x minus 7 plus 9 equals 2x plus 10. And we're going to solve this for x. So let's combine like terms. We get 3x plus 2 equals 2x plus 10. I'm going to go ahead and subtract 2x from both sides, and we'll end up with x plus 2 equals 10. And then subtracting 2 from both sides, we'll find that x equals 8. Now we need to find AB. So we know that AB equals 3x minus 7. So we want to go ahead and substitute in. So 3 times 8 minus 7, which tells me that AB equals 17. Okay, next one. A is on PQ. All right, so let's draw this. We have a segment, PQ, and A is somewhere on there. Okay, then it gives us a little bit more information. B is the midpoint of AQ. So I'm going to put B on here. And then remember, midpoints are right in the middle, which means that the two segments that it creates are congruent, right? The same in size and shape. So I'm going to put my congruency markers right on there. Now it tells me that BQ is 5 and PA is 12. Find PQ. So we're looking for the whole big shape. Now, one thing I know about congruence markers is that it means that those two segments are the same in size and shape. So if BQ is 5, then AB is 5 because they have the same congruency markers. Now, if I want to find the big segment, I just add all of its little pieces together. So 12 plus 5 plus 5, this is going to be what PQ equals. So it tells me that PQ equals 22. Let's do another one with a midpoint. X is the midpoint of CD. So we have segment CD, X is the midpoint. Anytime I have a midpoint, I always want to indicate the congruencies on either side. So it tells me that CX is 4x plus 6, and XD is 6x minus 4. Find CD. So it wants us to find this overall figure. So I know from the segment addition postulate that CX plus XD equals CD. But right now that's not very useful to me because if I plug my information in, 4x plus 6 plus 6x minus 4 equals CD, I have two unknowns. I don't know what X is, and I don't know what CD is. And that's a problem. We can't solve an equation with two unknowns. So we have to do something first. And what I have to do is recognize that those congruency markers, right, it means their measurements are equal. So anytime we have two congruent segments, we can set their measurements equal to each other. So I know that CX, the measurement of CX, equals XD because of that midpoint. So let's solve that first. So we have 4x plus 6 equals 6x minus 4. I'm going to subtract 4x from both sides, and we'll get 6 equals 2x minus 4. Add 4 to both sides, and we get 10 equals 2x. Dividing both sides, we find that 5 equals x. Well, now I can substitute that in here. 4 times 5 plus 6 plus 6 times 5 plus 4, nope, minus 4 equals CD. And we can go ahead and calculate that real quick. So we're eventually going to get that 52 equals CD, or CD equals 52 as our final answer.